In level 2, we will be shifting parent functions horizontally and vertically. And there are 4 different types of transformations: up, down, left, and right. This first transformation, as long as c is a positive real number, would, with a number added on the outside of the function, it shifts the function up c units. So a vertical shift up c units. And the next one would be a shift down when you subtract a number. So also a vertical shift down c units. When you add or subtract a number on the inside of the function, it's a horizontal shift, but you will find that everything that happens on the inside of the function is counterintuitive. So when it says minus c, we would think that you would shift to the left in the negative direction, but that's not the case. We actually shift to the right in the positive direction. So this is going to be a horizontal shift c units to the right. So we're going in this direction. This was up, this was down. And this next one, when we add a number, we would think we'd go to the right, but you do the opposite. You go to the left. So this one's going to be a horizontal shift c units to the left. So the things, when we have a number added or subtracted on the outside, it's a vertical shift up or down, and it's exactly what you would expect. If we add a number, we go up. If we subtract a number, we go down. But when we add or subtract a number on the inside by x, it affects it horizontally, and it's counterintuitive. So the minus actually goes in the positive direction, the plus goes in the negative direction. It's very important to know what your parent function looks like before you transform it. So if we look at this first function, f of x equals x squared, it looks like this. We start at the origin, over 1, up 1, 2 squared is 4, 3 squared is 9, and we have mirror images of those points over here if we reflect it across the y-axis. So we have to know what our parent function looks like, and then we're going to shift it. So if we want to shift this function according to this transformation right here, the minus 3, we would think that that would shift to the left 3, but it actually goes to the right 3. And the plus 1 is up 1. So all of the points on this parabola are going to go right 3 and up 1. So I start by moving the vertex of the parabola from the center, or the origin, right 3 and up 1, and I get the point 3, 1. Then I follow the same shape of the graph. From that point, I went over 1, up 1, over 2, up 4, and over 3, up 9 is going to land right here. And then I go left 1, up 1 from the vertex, left 2, up 4, and left 3, up 9. So the shape of the graph did not change. I just shifted all of the points right 3 and up 1. In the next example, first we need to think about the absolute value of x. That also starts at the origin, and it's 2 straight lines. It makes a V. The slope of this line is 1, so I go over 1, up 1. And the slope of this line is -1 over, so up 1, left 1, and we get a V shape. And now when we transform this, we shift it, the +2 is going to be 2 units to the left, and the -4 is going to be down 4. So I take the vertex of the parabola that started at the origin, and I go left 2 and down 4. Then I follow the same shape of the graph, the slope of 1 going this way, and the slope of -1 going this way. It's important to be able to look at a function and describe the shift for any function, and this is actually written as a generic function. It could apply to any function. Whenever you have a number added or subtracted on the inside, that is your horizontal shift, and on the outside, that's your vertical shift. So this graph is shifted 1 unit to the right. Remember, the -1, we would think it would go left, but it actually does the opposite, it goes right. But then the +3 is exactly what we would expect. It's shifted 3 units up. Also, to write this function, if f of x is an absolute value of x, and that's what we're transforming, to write g of x in terms of an absolute value, we would write g of x equals the absolute value of x minus 1 plus 3.